Hello everyone. Today we are going to see STP, that is spanning tree protocol. Okay, spanning tree. We are going to see spanning tree protocol. Let me select the brush. Okay, and we are going to learn STP. Okay, now before we understand what STP is, we have to understand how any layer 2 switch will handle the traffic, okay, especially the broadcast. Okay, so a layer 2 switch is part of a single broadcast domain. It will forward both broadcast and multicast frames out of every port other than the port on which it has received the frame. So if switch A is receiving anything from switch B, it is going to broadcast that or going to send that traffic to switch C as well as to all other ports except the port on which it has received. Okay, so if switch A has received the traffic on this port, okay, it's not going to send the traffic back even if it is broadcast to this, because it has received on this port. It's going to send it to all other ports, that includes switch C, but it's not going to send it to this port. So that's how the basic functioning of broadcast traffic is. Now if a switching loop is introduced in a network, that means if there is any packet just keeps on revolving around and around, if it is something started from switch D, okay, and it just keeps on going to switch B and A, then C and E and back again to D, we call that as a loop is created. Okay, so if a switching loop is introduced in a network, a destructive broadcast storm will develop within a few seconds. Okay, we call it as a broadcast storm. Broadcast domain is generated when broadcasts are endlessly forwarded in the loop. Ultimately, the storm will consume most of your bandwidth. Okay, it doesn't really matter whether it is 1 Gbps of your bandwidth. If it is a bigger network and if the broadcast keeps on going, it will probably consume most of your bandwidth, if not all. Okay, it will make the ports and the switches more busy, which eventually will bring down whole of the network. So that is where the STP is really helpful. Okay, now if you take this example that we have been seeing, okay, if you consider the same example, let's assume that you have a host A connected to switch D. Okay, let's say you have a host A here. Okay, let's call this as host A. Okay, host A is connected to switch D. Okay, and host A sends out a broadcast traffic for whatever reason. Okay, switch D, as soon as it receives the traffic, will send out to all connected switches. It is going to send it to the switch B as well as it's going to send it to switch E also. Those two switches will in turn send traffic to switch C and switch A. Okay, so from switch E it is going to go to switch C, and then from switch C it is going to go to switch A. Similarly, from switch B it is going to go to switch A. Okay, so both of them are going to send the traffic to switch A. Switch A in turn will send out traffic received from switch B and C, and traffic received from both the switches. This means there are two separate broadcast storms cycling in opposite direction. The one which is coming from switch, okay, switch D send it to switch E, switch A sends it to switch C, and switch C sends it to switch A. Similarly, the traffic received from switch D by switch B goes to the A. So there is going to be a kind of an cross section, the traffic flowing from this direction, okay, and the traffic flowing from this direction. All right, so they kind of we go into the opposite directions and forming two loops, because this traffic eventually is going to end up here and this traffic is eventually going to end up here. All right, without STP, the only way would be to remove one of the looping cable or power down the switch, but that's not a good situation. So How does then spanning tree help us resolve this issue? Okay, spanning tree protocol was developed to prevent the similar kind of broadcast storms caused by the switching loops. Switches running STP will build a map or topology of the entire switching network. STP will identify if there are any loops somewhere and then disable or block as many ports as necessary to eliminate all loops in the topology. Okay, though I have taken an example of showing this you as the block, but that's the STP will have to take a decision based on some calculations whether it is appropriate to block this port, I mean this side, or is it appropriate to block this port or this or whichever it is, right? But it's going to block to avoid or to break that loop. Now let's see how STP works. STP switches exchange what we call as the BPDUs. Okay, they exchange BPDUs with each other. That's called as bridge protocol data units with other connected switches to build the topology database. So they will have a database built which will have a lot of information available in it about the switches and which port it is connected, what is the bandwidth, and few other things, right? But essentially it's going to build a topology database. Switches sends BPDUs using a unique MAC address from its origin port and a multicast address as destinations. So it's going to send it as a broadcast, as a multicast destination MAC address, which is unique. This BPDUs are forwarded out all ports every 2 seconds, right? So this BPDU from switch A, switch B, switch C, switch D and switch A is going to be forwarded every 2 seconds. There are many steps involved in building STP topology. The steps are, like a root bridge is elected. So let me just clean this up a little bit and let me try to move this. Will list down all the steps. Okay, so the first step involved is, let's expand this a little more. So we have a lot of space to work. Okay, so the first step is going to be step 1. Okay, it's going to elect a root bridge, or we call it as switch. So it's going to select out of this 5 switches here, switch A, B, C, D and E. It's going to select which one is going to be the root bridge, though I have mentioned here, but there's a process involved in that. Okay, the second is that root ports are identified. The second step is that root ports identified. Okay, the third step is that designated ports are identified. Designated ports. Okay, it's going to identify designated ports. Okay, and the fourth point is to break the loop. Okay, one or many ports are placed in blocking state. Ports in blocking state. All right, sounds good. Okay, I'll have to pause the video here because I cannot make more than 10 minutes of video, and then I'll go into the part second. Okay, so I'll see you in the part second. Thanks.